Hello friends, my name is Suvarna. We were looking about the collection framework algorithms in the last session. Okay, so today we will move forward with the same algorithm, some remaining algorithms, and some new topics related to collection framework. Okay, so we will look at this one by one as usual. Static T list, T synchronized list, list T list, returns a thread safe list backed by list. Static KV map KV synchronized map map KVM returns a thread safe map backed by M. Static T set T synchronized set set TS returns a thread safe set backed by S. Static KV sorted map KV synchronized sorted map KV SM returns a thread safe sorted map backed by SM object. Okay. Static T sorted set T synchronized sorted set T SS returns the thread set backed by SS. Static T collection T unmodifiable collection object returns an unmodified collection backed by C. Static T list T unmodifiable list T extends T returns an unmodifiable list backed by list. Static KV map KV unmodifiable map extends K extends V M returns an unmodifiable map backed by M. Static T set T unmodifiable set T returns an unmodifiable set backed by S. Okay. Static KV sorted map KV unmodifiable sorted map K extends VSM returns an unmodifiable sorted map backed by SM. Static T sorted set T unmodifiable sorted set T SS returns an unmodifiable sorted set backed by SS. Okay, so we have seen so many methods now. Several of these methods can throw class cast exception, which occurs when an attempt is made to put compare incompatible types, or an unsupported exception operation exception is thrown, which occurs when an attempt is made to modify unmodifiable collection. Okay, so we have seen that collection can be modified or unmodifiable. Okay, so if you want to modify an unmodifiable collection, it will throw unsupported operation exception. Otherwise, it will throw class cast exception. Other exceptions are possible depending upon the method. Okay. Now we will see one more thing, that is set of checked methods such as checked collection, which returns what the API documentation refers to as dynamically typesafe view of a collection. Okay. This view is reference to the collection that monitors insertion into the collection for type compatibility at runtime. Okay. So what is dynamically typesafe view of collection? It is a reference to the collection that monitors insertion into the collection for type compatibility. Okay, so whenever you are going to insert any new object or any new thing into the collection, it will check for the type compatibility. Okay, if you are storing creating a collection of type string and you are trying to put a boolean value into that, it will not allow to insert that at runtime. An attempt to insert an incompatible element will cause a class cast exception, and this is useful during debugging because it ensures that the collection always contains valid elements. Those are needed. Okay, if you are trying to store boolean or float or anything else into the string or into the integer, it will always throw an error or class cast exception. Related methods: check set, checklist, check map, and so on. Okay, now they obtain a typesafe view for the indicated collection. Notice that several methods, synchronized list and synchronized set, are used to obtain synchronized copy of the various collection. So there are methods available, synchronized list and synchronized set, to obtain synchronized copy of the various collection. None of the standard collection implementation are synchronized. you must use the synchronization algorithm to provide synchronization. Okay, by default they are not synchronized. If you want the synchronization into your code, you will always provide by your own. Iterators to synchronize collection must be used with synchronized block. Okay. Whenever you are iterating through a synchronized collection, okay, so none of the standard collection are synchronized. Okay, if you want to synchronize it, you will do what? You will synchronize by using the synchronization algorithm provided. And one more thing, if you want to iterate through that collection which is synchronized by your own code, you have to provide the iterator into the synchronized block. Okay, so outside block will be also synchronized, and inside collection iteration will be also synchronized. The set of methods that begins with unmodifiable returns views of the various collection that cannot be modified. Okay, this will be useful when you want to grant some process read but not write capabilities on a collection. Okay, whenever set of methods, whenever you are a set of methods return type begin with unmodifiable. Okay, so those cannot be modified as the name suggests. Okay, and what is the use of this? When you want to grant some process read but not write capabilities on a collection. If you want to read only, give a read only collection type, it will be read only. And if it is put unmodifiable keyword in front of it, it means it cannot be written. It cannot be modified, or it cannot be overwritten. Okay. So collection defines three static variables: empty set, empty list, and empty map, and all are immutable. Now we will see some algorithms into one program. It create and initialize a linked list. The reverse order method returns a comparator that reverses the comparisons of the integer object. So for reversing, what we are using? Reverse order method. Okay, list elements are sorted according to whatever comparator object we are providing over here, and then they are displayed. The list is randomized using shuffle method, and then its minimum and maximum values are displayed. So what is the use of shuffle method? It will randomize the code. Now we will see that algorithm in short. Create and initialize linked list of type integer, adding elements -8, -20, -8, 20, -20, and 8. Reverse order comparator, collection dot reverse order. Okay, so from positive to negative, it will go reverse direction. Collections dot sort linked list dot and R with reverse order. How to compare? First of all, what is the largest value? 20. Then smallest value 8. Then smallest value -8, and then more smallest value is -20. So list sorted in reverse with for each loop I am iterating over here, and I am printing over here the displayed values reversed. Then I will randomize them, and then randomized list is displayed using the for each loop, and 28 -8 -20 with shuffling. It can be random at any time with new randomization. Okay, not every time you will get same result. Minimum value of this is -20, and maximum value of shuffled collection is +20. Minimum and maximum operate on the list after it has been shuffled. Okay, neither requires a sorted list for this operation. Okay, so minimum and maximum itself is a method return. It is a by default method return to find out minimum and maximum. Okay, now we will see about array. Array class provides various methods that are useful when working with arrays. These methods help bridge the gap between collection and array. Okay, so array is a class provided. So what it will do? It will create a bridge between collection and array. Each method defined by array is examined here. The as-list method returns a list that is backed by a specified array. So array will be displayed as list. Okay. So before this, in previous sessions, we have seen the toArray method. So it will convert the collection to array. Here, as list will convert the specified array into the list representation. Both the list and array refer to the same location. Now, static T list as list T array. So whatever type array you are specifying over here, same type T will be over here. It will be returning. If your array is of type integer, it will be return the integer list. If your array is of type string, it will be returning the string list. If your array is of type float, it will be returning the float list and so on. Array is the array that contains the data. The binary search method uses a binary search to find a specified value. Okay, this method must be applied to sorted arrays. For binary searching, your array must be sorted. Okay, so you have to remember this. If you want a binary search to find a specified value, what you have to do, you must provide sorted array. Sum of its forms of binary search, and whatever array you are specifying, it must be sorted. Okay, byte array, byte value, integer binary search, character array, character value, double array, double value. Okay, float array, float value, int array, int value, long array, long value, short array, short value, object array, object value, T type of array, T value, and comparator object. Okay, so everything is returning an integer. So you have to remember this. And which type of array it can be passed? Byte, character, double, float, int, long, short, and object. And also T type of array. Okay, and in Java 6, they are adding several other methods for binary search. What is the condition? You have to remember it. You have to provide the sorted array. Array is the array to be searched and value is the value to be located. The last two forms throw class cast exception, object and type. Okay. If array contains elements that cannot be compared, for example, double and string buffer, or if value is not compatible with types in the array. So you have to take care of this, what you are providing over here. The comparator C is used to determine the order of the elements. Okay, so comparator, we have already seen comparator interface, how we are implementing it. So it will determine the order of the elements. In all cases, if the value exists in the array, index of the element is written. Otherwise, a negative value is written. Okay. What is the integer over here? It is returning the index. Okay. It is not the element. It is returning. So you have to remember this. Integer is the index. So index always be positive and index always be integer. Okay. So for all the cases, it is returning integer value. And if value exists, it will be returning that index. Otherwise, negative value is written. The copy of method was added by Java SE6. Okay. It returns a copy of array and has the following form. So several other methods that we have seen that those are added by Java 6. The copy of is the method that is added. So we will see the forms of copy of Boolean copy of Boolean source integer length, byte copy of byte source integer length, character copy of character source integer length, copy of double source integer length, copy of float source integer length. Then integer source integer length, long source long integer length, short source integer length. Everything is returning array over here of the same type that you are passing. Okay. So whatever array you are passing, it will returning the copy of that array. Okay. So short array, copy of short source integer length, and T copy of T source integer length, T copy of U source integer length, and class extends type T, result T. The original array is specified by source and the length of the copy is specified by length. Copy is longer than source, then the copy is padded with the zeros at last. Nulls for zeros for numeric array, null for object array, and false for boolean array. Okay, copy not necessarily as equal to your original source. So if it is longer, it is padded, that is at the end they are put with the zeros for numeric array, null for the object array, false for the boolean array. If the copy is shorter than source, copy is truncated, all the remaining entries are deleted. Okay, in the last form the type of result T becomes the type of array return. Type of T, resulting T is the type of result T becomes the type of array result. Okay, this is result T is equal to type of the array what is you are returning. If length is negative, negative array size exception is thrown, so length should always be positive. If source is null, null pointer exception is thrown. If result T is incompatible with the type of source, an array store exception is thrown. Why? Because it does not understand what you are going to store it into. The copy of range method was also added by Java 6. It returns a copy of range within an array and has the following formats. Okay. So we have seen first of all copy of method. Now we will see the copy of range method. Static boolean copy of range boolean source integer start integer end. Copy of range source boolean byte source integer start integer end. Here also the same array that we are passing over here will be written over here. Okay. Copy of range character source int start int end. Double copy of range double source int start int end. Float source start end. Then integer source integer end. All of these are arrays and all of these are returning the array. Okay, so integer source int start int end, long source int start int end, short copy of range short source int start int end, t copy of range t source t start t end, and copy of range u source int start int end, and class extend t result t. Okay, original array is specified by source. Then range to copy is passed via start and end. Okay, this is, of course, is the original one, and range is given between start and end. The range runs from start to end minus 1, so always index start from 0. If the range is longer than the source, then the copy is padded by zeros. It's numeric array, like the copy of method, null for object array, false for boolean array. In the last form, type of result T becomes the type of array return. Okay. If start is negative or greater than the length of the source, array index out of bound exception is thrown. Okay. Negative that we understand, but why greater? For example, if your array is having data up to 4th index and you are starting to copy from the range 5, so it will give you array index out of bound exception. Seriously. Okay, because there is no index present that is 5 in that array. And if it is negative, so index cannot be negative at any time. Okay, in any cases, index cannot be negative. So for that purpose, it will throw array index out of bounds exception. If start is greater than end, illegal argument exception is thrown. If source is null, null pointer exception is thrown. If result T is incompatible with the type of source, and array store exception is thrown. Okay, so same errors are there like a copy of method. Okay, so we have seen copy of method and copy of range method. Okay, so equals method returns true if two arrays are equivalent, otherwise it returns false. So now we will see equals method. Static boolean equals, it all returns boolean, equals boolean array 1, boolean array 2, byte array 2, character array 2, double array 1, double array 2, float array 1, float array 2, boolean equals integer array 1, integer array 2, long array 1, long array 2, short array 1, short array 2, object array 1, object array 2. Okay, so to remember all of these methods, okay, what you have to remember only is the generalized syntax. Okay, what is the generalized syntax, and plus which type of primitive types are allowed. Okay, so if you want to remember, for example, this equals method, 9 methods are there. If you want to remember them to actually apply in your code, what you will do? You will first of all remember this, it is static. Second one, it is a boolean. true or false. It is the equals. Name is equals, all cases small. Then array 1 and array 2. And which type of primitive types are allowed over here? Boolean, byte, character, double, float, int, long, short, and object. Okay, only this much you have to remember, and all else are same. Okay, so no need to worry about how I will remember it. Okay, when you will apply it in your project, you will understand how it is used. Array 1 and array 2 are two arrays that are compared for equality. As simple as that. Deep equals method can be used to determine if two arrays which might contain nested arrays are equal. Okay, if one array is containing another array, the deep equals will check for the equality of such arrays. Static Boolean, deep equals object A, object B. It returns true if the arrays passed in A and B contain the same elements, and if A and B contain nested arrays, then the contents of those nested arrays are also checked, because the name itself suggests as deep equals. If returns false, if the arrays or any nested arrays are different for any particular index, the fill method assigns a value to all the elements in an array. In other words, it fills an array with a specified value. The fill method has two versions. So next method we are going to see is the fill method. What it does, assigns a value to all elements in the array. Okay. So fill with a particular value. If it is an integer array, fill with particular value like 5. It fills an array with a specified value overall. Fill method has two versions. The first version has the following form. Fills an entire array. Static void fill. Boolean array, Boolean value. Byte array, byte value. Character array, character value double, array double value. Float array, float value. Int array, int value. Long array, long value. Short array, short value. Object array, and object value. So what you have to remember it? You have to pass the first one is array, second one is value. Whatever value you will specify. For example, if you are specifying here true, all the complete array will be filled with true. If you are specifying here false, all the complete array will be filled with false value. Value is assigned to all elements. Remember this, all elements will be filled with the same value in an array. Second version assigns a value to a subset of an array. Okay, if you want to change only a particular range in the particular array, okay, from for example, from index 2 to index 5, in the 10 elements array, you want to change with a particular value. What you will specify? You will use this version of the fill method. You will specify first array, then your start, then your end, and then your value. For example, if there are 10 elements, and then you want to change the value, then you will specify the start index and end index, array, and the value to be filled. Okay, so there are the primitive types used are Boolean, byte, character, double, float, integer, long, short, and object. Okay, value is assigned to elements in array from position start to n minus 1. These methods may all throw an illegal argument exception if start is greater than n, or array index of out of bounds exception if start or end both are out of bounds. Sort method sorts an array so that it is arranged in ascending order. So next method you have to remember is sort method. How it will sort? It is arranged in ascending order. Okay. Previously we saw one method. For that method, we required that array must be sorted. Okay. So for sorting, sort method is provided. Sort has two versions also. So for sorting, you have to just pass the array. First version, as simple as that. How many primitive types are allowed over here? Byte, character, double, float, int, long, short, object. And T array, comparator, object. Okay, and it is returning type T. Okay, array is to be to be sorted. C is the comparator for the last form that is used to order the elements of the array. The last two forms can throw a class cast exception. Why? Because there is an object and the type. Okay. Then last two forms can throw class cast exception if elements of array are not comparable. The second version of sort enables you to specify range within an array that you want to sort. So only particular part of the array will be sorted, not all. So it forms R sort array start end character sort byte array start and end. Then sort character array start end, double array start end, float array start end, int array start end, long array start end, short array start end, object array start end, t array t start t end, and comparative object. Here the range begin at start running through n minus 1. T is a comparator in the last form that is used to order the elements of array. Whatever criteria you are going to sort the elements of the array, that will be saved in this comparator object. All of these methods can throw an illegal argument exception if start is greater than end, like the previous version of sort, or an array index out of bounds exception if start and or end is out of bounds. Okay. Last two forms can also throw class cast exception if elements are array are being sorted are not comparable. Okay. What is that or not comparable? The elements should be comparable. If those cannot be compared, those cannot be sorted. For that purpose, it will throw an class cast exception. Arrays also overrides toString and hash code for the various types of arrays. Deep toString and deep hash code are also provided, which operate effectively on arrays that contain nested arrays. The following program illustrates how to use some of the methods of the arrays class. So now we will see some examples. Array demo. So one array is created. Array of I is equal to -3 into I. Okay. So we will see -3 into 0 will give you 0 for the 0th index, then 1. -3 into 1 will give you -3. 2. -3 into 2 will give you -6, and so on. Display sort and display the array. Original contents are 0, -3, -6, -9, and so on. Now we will sort them, and then sorted array is displayed. Okay. Fill and display the array. So now, first of all, we are passing the array, then start index, and then end index, and then minus. Okay. So in between, from starting index 2 to ending index 6, whatever the result is will be overwritten by this -1. Okay. After fill, we are displaying the array. Again sorting the array. After sorting again, we are again displaying the array. Okay. So now binary search. For that, we need the sorted array. The value 9 as -9 is that location. So for we are providing the sorted array here. Arrays.binary search array -9. Okay. So what we are searching over here in this particular sorted array, we are searching for the -9 value, and its index is written, and its index we are displaying over here. So display method is written for one time only. So no need to write for each type for loop again and again. So display method is created over here, and array is passed. For each particular I in this sorted array, we are printing this I. So now original contents are 0, -3, -6, -9, -12, and up to -27. Because the loop will iterate through 0 to 9. It will not iterate to 1 to 10. So your 3's table is not completely displayed over here. It will be starting from 0 up to -27. Then sorted in the order, actual order, from lesser number to greater number, because it is a negative values. So highest negative value will be your lowest value, and lowest negative value will be your highest second value. Then -27, -24, -21, and so on up to 0. Then in between, from index 2 to I think 6, it is filled by your -1 value. Again, we are sorting it minus 27, minus 24, minus 9, minus 6, minus 3, and all the remaining minus ones here, and then 0. And the value now minus 9 is at location 2, 0, 1, 2. Okay, in the with the binary search method. Okay, so now we will see next one topic is why generic collection. The entire collection framework was refuted for the generics when JDK 5 was released, because type safety was very much important thing that was introduced in generics, and after collection introduction, if the objects we are going to store into collections are not type safe, it can throw the your runtime exceptions, and those are very critical to understand and very critical to remove. For that purpose, generics were introduced, and collection were also repeated for generics after JDK 5. The collection framework is arguably the single most important use of generics. Okay, so generics is introduced, and again, collection framework was the single most important use of generics. Generics added type safety, and which is very important thing for the collection framework. Before moving on, it is worth taking some time extra to examine in the detail significance of this improvement. Okay, so we will begin with an example that uses the pre-generic code. Old style. The following program stores a list of strings in an array list and then displays the contents of the list. Array list created with the name list. Okay, so added. This line stores strings, but any type of object can be stored. In old style, there is no convenient way to restrict the type of objects stored in a collection. 1, 2, 3, and 4. Now we will iterate through. While iterator has next, get the next element and convert it into string and then display. Retrieval element explicit typecasting is needed because any type can be stored, because the collection stores only objects. Okay, so there is no restriction. Explicit casting is needed. Then string is string.length characters long. So for particular value, we have to cast it and then display. Prior to generics, all collections stored references of type object. This allowed any type of reference to be stored in a collection. Okay. All collections that we were using without necessarily we specify in the angle brackets as object O capital, they were by default of type object. And since object is the main class for all the objects, any type of reference can be stored. It can be integer, it can be float, it can be string. And for retrieving, we had to do what? We have to cast to your particular type. The preceding program uses this feature to store references to objects of type string in a list, but any type of reference could have been stored. Okay, but unfortunately, the fact that pre-generics collection stored object references could easily lead to errors. Okay, before the introduction of generics that added type safety, whatever object could be stored into it, and it could easily lead to errors. It required that you, rather than the compiler, ensure that only object of the proper type is stored in a specific collection. So every time you should take care, you had to take care that what is going inside the collection, and for coming outside of the collection, you have to cast it. Okay. Then in the preceding example, list is clearly intended to store string, but you can store any type of reference. Okay. Nothing that actually prevent another type of reference from being added to the collection. The compiler will find nothing wrong with this line of code. List.add new integer 100. Okay. So if you can store integer over here, you can store it, because there is no restriction of which type of object you can store. But while taking out of the collection, you should cast it into your particular type. Okay. Because list stores object references, it can store a reference to integer as well as it can store reference to string. If you intended list to hold only strings, then the preceding statement would corrupt the collection. Okay, like a generics one, if you intended to only string type of value to hold, then the preceding statement would result an error. Again, the compiler had no way to know that preceding statement is invalid. The second problem with pre-generics is that when you retrieve a reference, you must manually cast that reference into proper type. This is why the preceding program casts the reference written by next to the string equivalent. Collections simply stored prior to generics were object by default. Thus, the cast was necessary compulsory when retrieving object. Aside from the inconvenience of always having to cast a retrieved reference with proper type, lack of type safety was also added, often led to rather serious but surprisingly easy to create errors. Okay, there was inconvenience every time when you want to retrieve any object from the collection. You have to explicitly cast it. You had to compulsorily cast it to your proper type. It added one more thing, that is a type safety error. Okay, serious error, rather serious, and surprisingly easy to create error. Because object can be cast into any type of object, it was possible to cast a reference obtained from a collection into the wrong type. Okay, object can be casted to any type. It is also possible to cast a reference. It was also possible to cast a reference obtained by a collection into a wrong type. So it can be cast to integer, it can be cast to string. Okay, if suppose if I am storing integer into it, and I accidentally forgot that I stored integer, and I want output as an integer, and I casted that into another representation like float or double. This can happen. Okay, so it is the wrong type, and that is the wrong unexpected output. If the following statement were added to the preceding example, it would still compile without error but generate runtime exception. If I am iterator.next, whatever is inside is string and whatever coming outside is integer. So it will give you runtime error. Recall that the preceding example stored only reference date, only instances of type string in the list, so you cannot iterate them as an integer. When the statement attempts to cast a string into integer, invalid cast exception is written. This happens at runtime. This is a very serious error. Okay, and it should be removed. And the addition of generics fundamentally improves the usability and safety of collections because it ensures that only references to objects of the proper type can actually be stored in a collection. Okay. So what is the advantage of generics? It improves the usability and safety of collection because whatever will go inside is proper, whatever is coming outside is proper. It ensures that only references to object of the proper type can actually be stored and retrieved. And this collection will always contain references of a known type. Known type means whatever is expected. Eliminates the need to cast reference retrieved from a collection. Instead, a reference retrieved from collection is automatically cast to a proper type. This prevents runtime error. Those are serious and those should not be there due to invalid casting and avoids an entire category of errors. And all the code is as simple as that to understand, as simple as that to learn, and as simple as that to remember. These two improvements are made possible because each collection has been given a type parameter that specifies the type of a collection. And what is the addition over here? Only this E, where E specifies the type of elements stored in a collection. So what is the modification? Array list string, list, new array list, so only string is allowed over here. Now only references of type string can be added. The iterator and list iterator interfaces are also generic. This means that the type parameter must agree with the type of the collection for which the iterator is obtained. Okay. So what is the type parameter? It must agree with the type of the collection for which you are iterating or looping. This type compatibility is enforced at compile time, which is the most important thing, and because of that, error will not occur. Now we will see modern approach of array list. Here string is added over here, so that only string will be added into the collection list. 1, 2, 3, 4 and added. List dot iterator will iterate and create the object of type iterator itr. The following statement will now cause a compile time error. You cannot create it like this, list dot iterator of type integer, because this is a string and iterator must also be a string 1. Why iterator dot has next? Directly you can iterate, no casting is needed. Now the following lines compile time rather runtime error, iterator dot next, and you are getting the integer because the type is string of collection. Array list, you cannot iterate as the integer, and string is dash dash character long. So whatever string length is there, it will be displayed. Now list can hold only references to object of type string. As the following line shows, there is no need to cast the return value of next into string. String iterator dot next, no cast is needed. This cast is performed automatically. Okay. Now, because of support of raw types, it is not necessary to immediately update older collection code. Okay. Raw type is still supported. Previous legacy code is still supported. So immediately you should not update. It is not necessary to immediately update the code, but all new code should use generic. It is recommended, and you should update older code as soon as time permits. Okay. Whenever you get time, please update your code, and that code should use generic. Okay. The addition of generics to the collection framework is a fundamental improvement that should be utilized wherever possible. And what is the advantage? It adds the type safety to collection as well. Now legacy classes and interfaces. Early versions of Java util did not include the collection framework. It defined several classes and interfaces that provide ad hoc methods for storing objects other than collection. When collection were added after Java 1.2, several of the original classes were re-engineered to support the collection interfaces. Thus, they are fully compatible with the framework. Okay, so everything is re-engineered. While no classes have actually been deprecated, one has been rendered obsolete. Okay, no classes are deprecated. All you can use that those ad hoc methods, ad hoc classes, but one is obsolete. Where a collection duplicates the functionality of the legacy class, you will usually want to use the collection for new code. Okay. Collection duplicates the functionality of the legacy class. Whenever your code is same as the legacy class code, and where collection framework can be used, it is possible. You will usually want to use the collection. That you will see that collection has so many advantages. It is so simple to learn and understand. You will want to use the collection for new code. In general, the legacy classes are supported because there is still code that uses them. Okay, there is still code available. None of the collection classes are synchronized, but all the legacy classes are synchronized. One main difference: none of the collection classes are synchronized, but legacy old code is synchronized. The distinction may be important in some situations. You can easily synchronize collections by using one of the algorithms by your own. Legacy classes by java.util. Before collection introduction are dictionary, hash table, property, stack, and vector. Okay, all are synchronized. New collection classes are not synchronized. But if you want to synchronize collection to, what you will do? You will use the algorithm provided by collection. There is one legacy interface called enumeration. The following sections examine enumeration and each of the classes in turn. So what are the classes? Dictionary, hash table, properties, stack, and vector. Okay. Enumeration interface. The enumeration interface defines the methods by which you can enumerate the elements in a collection of objects. What is enumeration? Obtain one at a time. This legacy interface has been superseded by iterator. Okay. Obtain one at a time is now replaced by iterator. Although not deprecated, enumeration is obsolete for now. for new code. However, it is used by several methods defined by the legacy classes like vector and properties, is used by several other API classes, and is currently in widespread use in application code. Because it is still in use, it was retrofitted for generics by JDK5. Declaration is interface enumeration type E, where E specifies the type of element being enumerated. Enumeration specifies two methods. Boolean has more elements, E next element. Enumeration is as same as iterator, but it is used for legacy code because still raw code is still available for use. JDK5 is also using JDK5 generic is still using the enumeration. Okay, it is considered absolute. It is not deprecated interface. Okay, and whoever is using iterator, you can directly use the iterator interface. It is not compulsory to use the enumeration interface. How to use the enumeration method? Two methods are there. Has more elements. If the looping, whenever you are looping through a collection, if there are still more elements present, it will return true, and next element will give you the next element as a type E. Okay. When implemented, has more elements must return true while there are still more elements to extract, and false when all the elements has been enumerated or iterated. Next element returns the next object in enumeration. That is, each call to next element obtains the next object in enumeration. It throws no such element exception when enumeration is complete. Okay. Whenever you are going to next element, when the index is reached at last position, then it will last is not available, so it will throw no such element exception. Vector implements dynamic array, not a particular fixed length array. It is similar to array list, but now with two differences. It is synchronized first one, and it contains many legacy methods that are not part of the collection framework. With the advent of collection, vector was re-engineered to extend abstract list and to implement the list interface. With the release at JDK5, it was retrofitted for generics and re-engineered to implement iterables. Okay. When collection was introduced, vector was re-engineered to extend abstract list and to implement the list interface. And when release of JDK5, it was retrofitted for generics and re-engineered to implement iterables. Okay. Vector is fully compatible with collection, and vector can have its content iterated by the enhanced for loop. Okay, it is fully compatible. You can directly use the iterator interface to iterate through it. Okay, so what is the type? Its syntax: class vector type E, where E specifies the type of element that will be stored. Here are the vector constructors: vector integer size, integer increment, vector collection, extends E, C. The first form, that is the default constructor with no parameters, creates a default vector which has initial size of 10. Second form creates a vector whose initial capacity is specified by size. Third form creates a vector whose initial capacity is specified by size and whose increment is specified by increment. For second, you will specify size. For third, you will specify size and increment. The increment specifies the number of elements to allocate each time the vector is resized upward. What is the increment? Every time vector is full, how many elements should be incremented? You will specify using the increment, and it is the integer value. And last is creates a vector that contains elements equivalent to collection object. All vectors start with an initial capacity. After this initial capacity is reached, the next time that you attempt to store an object of the type in vector, the vector automatically allocates a space for that object plus extra room for additional objects. More than just required memory, vector reduces the number of allocation because the time complexity is reduced. So every time it allocates more than required memory, and this reduction is important. The reduction of number of allocation is important because allocations are costly in terms of time. Okay, even if that time seems to be in milliseconds or nanoseconds or whatever, that microsecond, this allocation takes time, and for large programs that time is very much important. The amount of extra space allocated during each allocation is determined by the increment that you specify. Okay, if you don't specify, vector size is doubled every time. your vector is size 10, it will be doubled 20. Then again the vector is full with 20, it will be again doubled as 40, like this. Vector defines these protected members: integer capacity increment, element count, and element data array. The increment value is stored in capacity increment. The number of elements currently in the vector is stored in element count. The array that holds the vector is stored in element data. Okay. So what is capacity increment? It is stored. Capacity increment stores the increment value, how much you have to increment. Number of elements currently in the vector is stored in element count. The array that holds the vector is stored in element data. In addition to the collection method defined by list, vector defines several legacy methods. Okay. Vector implement list. You can use vector just like you use array list. Okay. Also manipulate one using its legacy method. This array list instance. After you instantiate vector, you can add an element using add element using its legacy method. To obtain the element at specific location, call element add. To obtain the first element in the vector, call first element. To retrieve the last element, call last element. You can obtain the index of the element by using index of and last index of. To remove an element, call remove element or remove element add. Okay. So this way we have completed some topics related to your collection framework. Okay, we are come up to vector. In the next session, we will see the methods defined by vectors. Okay, in detail. So meet you in the next session. Thank you so much.